So guys, here in this question it is given that in the shown arrangement of experiment of the meter bridge, if AC corresponding to the null deflection of the galvanometer is x, so what would be its value of the radius of the wire AB is doubled. Okay, so he is asking what if this radius of the wire AB is doubled. Okay, so he is saying that so in this particular circuit, we have the meter bridge with the AC supply, and we have a galvanometer. So the null deflection happens at the point x, it seems. So the distance from the A to C is given as x. So that is the null deflection length, we can say. So at null deflection, we will write R1 divided by R2, so that will be equals to R3 divided by R4, that is equals to x divided by 100 minus x. Okay, and if the radius of the wire is doubled, then the resistance of AC will change, and also the resistance of the CB will also change. But since R1 divided by R2 does not change, because R1 divided by R2 value doesn't change, so we can write R3 divided by R4 should also not change at the null point, so therefore the point C doesn't change. Okay, so we can say the point C does not change. So according to that, the value will be x only. So this is the correct answer for this question. Thank you.
In this problem, we have given that this question has statement 1 and statement 2. Of the four choices given after the statements, choose the one that best describes into two statements. Statement 1 has higher the range, greater is the resistance of ammeter, and statement 2 is to increase the range of ammeter, additional shunt needs to be used across it. Okay, so we can see that we want to obtain an ammeter. Okay, and we can obtain it by connecting a galvanometer and a shunt in parallel with it. Okay, so if we are going to connect a galvanometer and a shunt, both are in parallel combination, then we will find an ammeter. Okay, so consider the ammeter has current I. Okay, initially, and we want to increase the range, that means we want to increase the magnitude of current. This is the purpose. Okay, so what we will have to change in the shunt resistance. Okay, so first of all, we have given in statement 1, higher the range, greater is the resistance of ammeter. So higher the range means current is high. Okay, current is a magnitude of current across the ammeter is increased. So we know that if this is the current Ig, okay, and this will be the current I minus Ig, then we can write Ig into Rg, that is the resistance of galvanometer, that is equals to I minus Ig multiplied by S. Okay, so from here S Ig into Rg equals to I into S minus Ig into S. Okay, now we can write Ig into Rg plus Ig into S upon S equals to I. Okay, so where S is the shunt resistance, so if we are going to increase the value of S, the current will decrease. Okay, the range will decrease, and we have given that higher the range, greater is the resistance of an ammeter. So from here we can say that for higher range, that means for higher range the resistance of ammeter should be less. Okay, resistance of ammeter should be less, and for this the shunt resistance should also be less, okay, or should also be decreased. So from here we can say, after the observation, that statement 1 is wrong, okay. Now let's talk to statement 2. To increase the range of ammeter, additional shunt needs to be used across it, okay. So as we can see that shunt is connected in parallel combination with galvanometer, okay. So if we are changing this shunt resistance to S dash by increasing it, so we are adding X resistance in S to increase it up to S dash, okay. So in parallel combination, the value of S dash will be less than S, okay. So as we know that S, when S will decrease, the current will increase, okay, because this is in parallel combination. And from here we can say that 1 upon x plus 1 upon s will be equals to 1 upon s dash, okay. So from here we can see that 1 upon x will be 1 upon s dash minus 1 upon x will be 1 upon s dash minus 1 upon s. So from here we are going to add x, but the new resistance will be decreasing, okay. So if we are going to add or increase the range of ammeter, additional shunts need to be used across it. That means that is the correct answer, because when we are going to increase the resistance, the range of the ammeter will increase, because the shunt, if the shunt resistance, the equivalent shunt resistance will decrease, so equivalent resistance of the ammeter will decrease and the range will increase. So we can say that statement 2 is correct. So from here we can conclude that statement 1 is false and statement 2 is true. That means option D is the correct answer of this problem. Thank you.
Hello, we are given with a question, and the question says in a meter bridge experiment, null point for an unknown resistance is measured. Now the unknown resistance put inside an enclosure maintained at a higher temperature. The null point can be obtained at same point as before by decreasing the value of standard resistance. Resistance of metal increases with increase in temperature. So statement 1 asks resistance, statement 2, resistance of metal increases with increase in temperature. So yes, since resistance is directly proportional to temperature, resistance increases, right? So R by X, the null point, is equal to L1 by L2, right? So the value of the null point at is should not be changed according to this point, right? If that should not change, R by X also should not change. So it should not change, right? So if X is if X increases, R also should increase. So this statement is false. So what is our answer? Statement 1 is false and statement 2 is true. So option D is the correct answer. Thank you.
Hello students, our question gives that consider two identical galvanometers and two identical resistors with resistance R. If the internal resistance of the galvanometer is Rc is less than R by 2, which of the following statements about any one of the galvanometer is true? Okay, four options are given here. So we can analyze each option one by one. Here, in the first two options, it is said about the maximum voltage range. So, in the first option A, it is said that maximum voltage range is obtained when all the components are connected in series. And in second option, it is mentioned the maximum voltage range is obtained when the two resistors and one galvanometer are connected in series and the second galvanometer is connected in parallel to the first galvanometer. Okay, so we can analyze the first two statements. For a conversion of the voltmeter, the galvanometer is connected and a resistor is connected in series with the galvanometer. So, galvanometer can be converted into voltmeter or ammeter. For the conversion of voltmeter, the resistance should be connected in series. So, what happens when resistor is connected in series? What happens is that we get the maximum voltage. The resistance increases and we get the maximum voltage. But in the case of the parallel connection, what happens is that the resistance decreases. So To conversion or to get the maximum voltage range, the resistance should be connected in series. So comparing A and B, our statement A is true because here all the components are connected in series. Okay, let's check C and D. Here it is said the maximum current range is obtained when all the components are connected in parallel with both resistors, and option D gives the maximum current range is obtained when the two galvanometers are connected in series and the combination is connected in parallel. So here also on the conversion of ammeter, on the conversion of ammeter, galvanometer into ammeter, the galvanometer is connected with the resistance called a shunt resistance parallelly. This is a shunt resistant parallelly for the conversion of ammeter. And this value of the shunt resistance should be least value. So to get a least value, the resistors should connected in parallel manner. So out of C and D, here the maximum current range is obtained when the resistors are connected in series manner. So the C options are true and option A is true. So our correct answer are the option A, the maximum voltage range is obtained when the components are connected in series, and option C, the maximum current range is obtained when the components are connected in parallel with the both resistors. Okay,